Hi, today I want to talk about an interesting little thing I had a look at the other day, and it's the cosine of I. What is the value of the cosine of the square root of -1, or the cosine of the imaginary number? So what I've done a little bit of working out, so we can take a look at that today. So first, let's look at this. It's the Argand diagram. I've got my real and imaginary axis. I've got the unit circle. And I've put a line with angle x. Now that will give us e to the power ix. Now I've done another line with an angle minus x. They sometimes call angles arguments in complex numbers. And that will give me e to the I minus x. Or I can rewrite that e to the minus x. Now that's both of them items in exponential form. Let's write them again in a rectangular form. So the first one's just cos x plus I sine x. And the other one would be cos x plus I sine minus x. But because the sine function is an odd function, I can change the minus x to a positive x and put a negative in front of the function. Okay, so we end up with these two equations. Now if I take them equations, 1 plus 2, add them together, I'll get this plus this here. The plus I sine x plus minus I sine x will disappear, and I'll end up with 2 lots of cos x. So I have the two exponential functions equal to cos x, rearrange for cos x, and I just divide both sides by 2, and I end up with this. Now this is the interesting part. If I replace x with I, the imaginary number, so everywhere I see an x up here, I replace it with an I get e to the I squared, and I squared is -1. I get e to the minus I times I, or minus I squared, which will give me minus -1, which will give me e to the power 1, or just e. Now the last bit, I end up with this, and I can just put that straight in a calculator. And if I do, I'll end up with a 1.54. And what's interesting about this is this number is greater than 1. And if you look at a cosine function, they tend to have an amplitude of 1. So that's pretty good. It ends up tying into the cos h function, hyperbolic functions. But yeah, I just thought that was really interesting and thought I would jot a few notes down and take a look at it. So if you've ever wondered about this, I hope this has helped you. It's quite a simple explanation. So thank you. Goodbye.